Let's look at the area model and partial products. When students first learn to multiply, they use the area model or the box model. This model allows for visual representation. The students can see the box and they know exactly where to put the numbers and how to multiply. Students will use their knowledge of place value to decompose a number into ones and tens. Remember that decompose means to break apart. For example, here I have the 23. Notice I wrote it in expanded form, 20 plus 3. So decomposing is the process of separating it. When it's written like this in this format, 20 plus 3, that is called expanded form. Let's look at an example in which we apply the area model to 23 times 35. We begin by decomposing the numbers. Remember, we are using place value to determine the value of each digit. Look at the 23. The 2 is in the tens column. The 3 is in the ones column. So that becomes 20 plus 3 in expanded form. Now let's look at the 35. We have 3 tens and 5 ones, which is 30 plus 5. Let's arrange these numbers around the box. Let's multiply. 20 times 30 is 600. 30 times 3 is 90. Let's go to the next row. Multiply by 5. 5 times 20 is 100. And 5 times 3 is 15. In order to get the final product, the students will add 600 plus 90 plus 100 plus 15. After students master the pictorial model or the area model, they will move to a concrete model called partial products. These two methods are very similar, so let's compare the two. On the left, we have the area model. Let's begin by multiplying 30 times 20, which is 600. Now let's move over to the partial products and let's try to find those numbers. If you notice in the tens column, we have the 2 and the 3. However, remember we're multiplying using place value, so that is really the 2 or 20 and 3 represents 30. So we are multiplying 30 times 20. Next, we're going to multiply 30 times 3, which is 90. In partial products, I circle the two 3's, however, they're different. This 3, the top 3, is in the ones place, and the bottom 3 is in the tens place. So we are really multiplying 30 times 3. Continuing, 5 times 20 is 100. We circle the 5 and not a 2, but a 20. The 2 represents a 20. So 5 times 20 is 100. 5 times 3 is 15. The 5 and the 3 are in the ones column, so 5 times 3 is 15. We add up all these products and we get 805. Remember, we do not use the word and. It is 805. Let's compare the three methods. Remember that the students begin with the area model or the box model so they can visualize the steps when they fill in the box. Then they proceed and apply the same ideas of place value in partial products. And then they move on to the abstract, which is the traditional method. We begin with pictorial. We can see the box and know where to place the products. We move to concrete and then to abstract. Here are some final thoughts. Remember, decomposing numbers will help students to develop multiplication fluency, and the students will be able to multiply large numbers using mental math. As the students visualize the decomposing and writing the numbers in expanded form, then they learn to multiply 2-digit and 3-digit numbers. So the area model provides a visual model for students to decompose the numbers they will multiply. Students in 3rd and 4th grade are developing at the pictorial level of understanding. The area model and partial product method uses place value understanding and then uses the properties of operations to perform multi-digit multiplication. So please underline the term place value. Remember, everything we do in 3rd and 4th grade centers around place value. The area model and partial product help students to develop a stronger conceptual understanding of the traditional algorithm. As the students begin using the visual model of area model, then they move on to partial products. The better they are at these two models, then they will master the traditional algorithm. I hope that this short video has helped you to understand partial products.